right. Thank you, Philip.
So,
Let me just get back. So, am I audible?
yeah, I can hear you fine. You're great.
Okay, cool. Thank you. Thank you so much. Yeah. Hello, everyone. And welcome to our talk. My name is Poduval, and my co-presenter, Kamal Vedantham, is also here. And we both from Amazon Lab 126, and I think our day jobs are to work on multimedia drivers, middleware, and since it's mostly a vertical, it spans across kernel middleware, and then we also come across Yocto on a day-to-day basis. And today's talk is going to be a collection, a mixed bag of certain experiences that we've encountered um, while trying to use Yocto to ship multimedia solutions. And the format we're going to be following is, we'll describe a problem and then what we did as a solution. Sometimes it's a workaround, and then so it's varied collection of different problems that we're going to be discussing. So with that, I'll get started. Okay. Yeah. So the first problem we'd like to talk about is speedy individual package build, right? So in our daily workflow, we use DevTool to check out individual packages that goes into the build and workspace directory. So the problem we're trying to solve is to make iterative development very fast. So one of the things we notice is when we build with Bitbake or DevTool, the build takes longer, and this is primarily due to recipe parsing. So that takes, depending on how many layers are there, it takes a bit of a time. Um, we needed something even faster. So one of the solutions here was to use the scripts inside the temp directory, build scripts. So by running them directly, we are going to be skipping the bitbakes parsing step. So inside, like once you DevTool a package, there would be a symbolic link to OE workdir, and under temp there is a do compile, a do install, various steps of the Yocto build process. And if you run this like with the add command, to compile, to install, followed by an SCP to transfer the image or the package binaries or libraries into the device directly, this process takes very little time as opposed to running a big command. So we found this very helpful. It does help improve productivity. We'd like to hear from the community at the end whether this is a good option or not. Okay, second problem. So this we encountered like when we use a specific Yocto version or a specific BSP layer. It comes with a specific kernel version, and now we had a use case where we needed to patch that kernel, and that patch was introducing some UAPI headers. So what we noticed is that the application that was trying to use this patch feature was unable to get those headers, and this is because applications do not directly build with kernel headers. They actually use another package called libc headers, right? And the problem statement was we didn't want to patch the libc headers because of unknown consequences, because there's a lot of other things that are getting built using libc headers. Um, so we needed a solution. So we for this particular problem, we reached out to the community, and we got several suggestions, including some to patch libc headers. But then I think Bruce pointed us to like a work in progress patch. It's called kernel alternate headers.bb class, and it had two modes of operation. So mode one was to include directly from a recipe, and so that inside the recipe sys root, you're going to get some of the exporter kernel headers. And then the second mode, which we didn't use, but what was to actually add it to the kernel recipe itself. So we ended up using mode one, and I think kernel alternate header dir was like a variable that pointed to the exported headers, and we just had to pass this into our package CMake as using OE expert flags, and then with that the package was able to build. So the next problem was this is kind of like a I would consider it to be a hardware issue where somewhere the hardware needed an extra reset, and it was fairly low level because this hardware was related to the system bus. And so there were a lot of debates about where to put this workaround for this hardware issue. So we did debate about putting it on Linux driver, but then it does impact multiple drivers. So we'd have to put it into early boot and where into early boot. And none of those solutions were looking clean. So I think, and we didn't want Linux to be aware of such low-level workarounds. So a good place to put it, we thought, after several rounds of debates, would be inside the bootloader. So we thought if it is an early boot, then by the time Linux comes up, we would already have the workaround in place, right? So this particular BSP we were working with, we found a mechanism in U-boot to make this hardware workaround. So it was basically like a reset, very early reset to some hardware IP to make sure that the bus is functional for the rest of the Linux boot. So we use the U-Boot's internal scripting mechanism, and I think with the append techniques of Yocto, it was fairly easy to do that. We had to do was to go and create a BB append and then provide a new U-Boot SCR scripting file that included this workaround. And the workaround itself was done using some low-level memory modification tools. So yeah, this kind of worked out well, and we didn't have to make any ugly changes to the Linux drivers or Linux in early boot. Uh, I I think the next few slides are from my colleague Kamal, so I'd like him to take over.
Yeah,
Kamal?
thanks, Karthik. Yeah, yeah. Can you, yeah, can you guys hear me?
Yeah, Kamal, you're audible.
Oh yeah, yeah. Okay, yeah. Thank you, Karthik. Yeah. First of all, yeah, thank you for having me opportunity to talk. Yeah, in this slide, we want to talk about a common scenario where between the teams, where we need to have a binary deployment for some teams, but for example, the vendors, and where we want to have a source deployment for the internal teams where we have access. So this is a common scenario, and that can be achieved by using the virtual providers in general. But Kat, if you can go to the next slide. Oh yeah. So in case of preferred provider, for example, for the same recipe, based on a build variant, for example, a vendor build or a source internal source build, we can use a preferred provider pointing to either libraries recipe or pointing to the source recipe. So that can be set at the recipe level, where we can say, okay, particular recipe or provides the same recipe name. So, but the preferred provider will be differentiating between is it a library or a source. So this will give a flexibility so that we can, based on build variant, we can give a binary to someone, or we can give a source build to the internal team. So with that, we don't need to expose any proprietary code when we are deploying this to the vendor side. So they'll get simply a pre-built library. So, and everything will be configured in the recipes with our provider, our provides and preferred provider and all. I think that's the main essence of the concept. Can we move on to the next slide, maybe? Yeah. I think the part of this problem is, okay, how to find what recipe provides the particular binary. I think Sergio, before one of the speaker, he covered partially this topic, but I just want to continue in terms of how we use it in when there is this binary problem. For example, there will be multiple binaries which we don't even know what recipe is providing them. So especially finding backtrack them for the recipe is like a nightmare. So how we know from where this recipe from binary is coming from. So I think to make that use, Acto provides a very nice tool, OE package data util that can, for example, if I want to find in a particular path, etc., where the media player configuration is coming from. So simply I can say OE package data util and find path of that particular with the full path, and then the utility will nicely give the name. Okay, the recipe name is the media player. So that's what the recipe and then I also wanted to check, okay, how many other files or how many other binaries this particular package provides. So we can use OE package data util list package files, and then we can input them the recipe name, and we'll get, okay, all list of all the packages that are provided by this particular recipe. And also we can also use Acto like a bitbake uh, S option, where we can go the show revisions for this media player. So it might give, for example, based on it might give the version number, or it might we might also get the git commit for this particular recipe, which is very useful in terms of finding and debugging what particular version of particular recipe we are using. And you want to go for the yeah. So the other problem we want to talk about is the package groups. So in general, in a complex project where there are multiple uh, package groups available, and we do not know what package group is really included in this particular image. So that is the problem we mostly face, because at Amazon the project scale is more, and we will be seeing more and more package groups that are part of the uh, workspace, but those are not part of the image. So that's what we wanted to figure it out. Okay, what package groups are included in this particular image, even though there are n number of package groups present in the workspace. So to make that easier, I think, as also Sergio pointed before, so we can use a dependency graph generation from the bitbake itself for the image. For example, we can say, okay, bitbake generate graph for my particular image, and that will generate what is included in this image. And from there, we can go and it will generate a dot file, and from there we can also get the list of the package groups that are included in the image. So to make simplify the statement, so we can simply, okay, cat the dependency dot, and particularly we can get the package groups that are included in the image. And for example, finally, what this package group adds to the image. So that we can also figure it out by grabbing a runtime variable from the package group itself, and that will list what are uh, the providers from the package group. So yeah, Karthik.
Okay, yeah, yeah. This might be a bit more debatable topic, like, but this is a real issue we face. So we do use state cache servers for doing speedier builds. However, we still don't, at least in our project, we don't have remotely hosted hash equivalence server. So we keep getting this warning, right? Local hash equivalents and have been configured in state mirrors. So what's this causing is packages that are coming from open source layers are getting rebuilt, probably because local hash equivalent server is generating a different hash for the same package as opposed to what's there in the state cache. So what we did, I don't know if this is recommended, but we basically went to the basic hash, and this did help to uh, save some build time. So, but of course, our longer term is to use a hash equivalent server and then point it. So that's something we are actively working on, but this current mechanism was used because I think it also depends on the nature of the build. In our build, we do have a lot of local BSP level changes and packages, and normally even though we have a state cache, there's a lot of frequent changes happening there. So there's a lot of rebuild happening with local packages that are in our layers, but we rarely have any changes in open source layers. So we really wanted those to come from the state cache, while you know local BSP changes to get rebuilt. So I think for that use case, this solution kind of did help with having a speedier build. But like to hear community feedback on this. Another problem we have is since we are maintaining multimedia BSP for our project, what we find is that there's lots of packages that we where there's a kernel, there's a loadable kernel module, there's a bunch of HAL libraries, there are test utilities, test scripts, and other tools, right, to verify this functionality. And I think we learned this probably the hard way that we every time someone builds a different application image, some of these utilities are missing, right? So how to make sure that all these utilities appear? So one solution was to actually create a package group that includes the driver, HAL, and all the test and test packages and tools. And then uh, since these are all relevant to a specific DSP, so we could use the machine essential extra R recommends as a mechanism to make sure that this collection of drivers, HAL, tools, and tests get included regardless of what application image you're building. So that is another thing that we found helpful. I think that is all we had. I wanted to also go back to one of the slides that Kamal spoke about, and I don't know, this is something we are again looking at the community for. Uh, so in case of source build versus binary deploy, right? At least our specific problem is that there are certain users who can look at the source, whereas the others who are supposed to only see the library, right? Because they are outside of the company and they are vendors that we are working with. So I was wondering if there's any sort of, is there any thought process around based on the current user decide whether to build from source or from binary. I think our current default is everybody is binary, and those who need the source will go and make the necessary changes to do that. So that's just an open question here. I think with that, our slides are done and we are open for questions.
Thanks for the talk. Do we have any questions? I haven't. Nothing obvious in the chat. That doesn't mean I didn't miss it. Okay, we have a question. You can have, it's sort of a comment. You can have two different distros for bin and source distribution. And then we have a question, how is the build performance when using this architecture configuration model?
Okay, so Kim, you say that you can have different distros for bin and source distribution. Okay, that's something we could do. But I was thinking more from a user's perspective because really certain users are allowed to build from source, other users are only meant to see the binary. So because these are like proprietary algorithms, so I was wondering, maybe we could improve our current with the distribution based approach, but I was just thinking more about can we make that decision based on who's building? So. And okay, the second question is from Oscar. I think you're probably referring to the hash equivalent server. Is that right, Oscar? Oh, okay. Yeah, I think by putting a OE basic hash, we found that all the packages that we were uh, not really developing for, but which came from open source layers, they were fetched directly from the state cache. So they didn't really uh, get built. Whereas the local uh, packages that come from our own layers, most likely they would have some changes and they were getting rebuilt. If they were not rebuilt, they were still coming from the state cache. So we did see probably like a 20 to 30% speed up in overall build time after making this change. I hope that answers the question.